Hello, my name is Preethi. I am working as an assistant professor, Department of EEE in SNS College of Engineering. Today, we are going to focus on 19OE117 Renewable Energy Sources, Unit 2 Wind Energy. Topic 4 Grid Integration Issues of Wind Power Plants. To integrate the large amounts of wind power into electricity grid, a number of issues need to be addressed, including the design and operation of power system, the grid infrastructure issues, and the grid connection of wind power. So, the transient stability and the power quality problems, say for example, consider a grid connected wind energy system. So, during a transient fault in the power network, the rotor speed of wind generator goes very high. That time, the active power goes very low and the terminal voltage goes very low, or we can say the voltage collapse will occur. So the wind speed might be considered constant during a transient fault. And also we have to maintain a supply demand balance, need flexible grid systems and the advanced forecasting techniques. So the wind energy does not suddenly trip the system off. The variations are smoother because there are hundreds or thousands of units rather than a few larger power systems, making it easier for the power system to predict and manage changes it applies. So the large-scale wind power can impact the grid stability due to the non-dispatchable nature. The solutions will include the grid modernization, energy storage, and the advanced control. So transmission constraints. So we have to focus on the location of the wind power plants and the smart grid technologies for the efficient wind power transport. And also we have to focus on the main thing, the grid connection requirements. The major requirements of typical grid codes for operation and grid connection of wind turbines are to be as the first one we can call it as the voltage operating range, the frequency operating range, the active power control, the frequency control, the voltage control, the reactive power control, and we can call it as the low voltage drive-through capability, high voltage drive-through capability. These are the various things we have to focus for the grid connection requirements. Then the grid codes and standards. It is essential for the seamless integration of wind power in compliance with frequency regulation, I told you know, the voltage control and grid connection requirements. And we have to focus on the islanding on auto reclosure. Critical situations can occur if part of utility network is islanded. An integrated distributed generation unit is connected. This situation is commonly referred to as the loss of mains or loss of grid. When loss of mains means we call it as LOM. When LOM occurs, neither the voltage nor the frequency is controlled by the utility supply. So normally, islanding is the consequence of a fault in the network. If an embedded generator continues its operation after the utility supply was disconnected, faults may not be clear since the arc is still charged. So mitigation strategies. So by means of advanced forecasting techniques and by means of using energy storage systems and the demand response, and also we can use the hybrid power plants, and there should be a collaborative efforts between the industry and the policymakers are very important for the successful integration. Then we have to focus on the other issues because there are some other problems concerning the integration of DG that will be called as the ferroresonance. The ferroresonance can occur and damage the customer equipment or transformers. For cable lines where faults are normally permanent. The fast blowing fuses are used as the overcurrent protection. So this is one of the problem. And also we can talk about the grounding. There are possible grounding problems due to the multiple ground current path. These are some problems may arise. Let's see about the case study topic, the Denmark's wind power integration. Denmark has efficiently integrated a large share of wind power into the grid, reaching up to 50% of electricity consumption on windy days. So there will be a strong government support because of these policies, and there is a good investment in infrastructure. There will be a collaboration between the industry stakeholders to optimize the wind energy production and the grid stability. So one of the case study we have referred here, and case study number 2, Texas wind energy integration. The Texas leads the United States in wind energy capacity with the wind power contribution over 20% of electricity generation, and the integration of wind forecasting technologies, use of market mechanisms such as the competitive wholesale electricity. So these two case studies lead to the grid integration. So my dear students, let's have the assessment part. How can the advanced forecasting techniques improve the integration of wind power into the grid? So please answer for this. And what roles do smart grid technologies play? Let me know the answer. So I have referred the two books, Joshua and Chetan Singh Solanki. And thank you for your kind attention. Thank you, students.